Yeah, g'day and welcome back to my channel. What's a power chuck and why are they used in industry? Alright, mail time. When Lawrence bought his lathe, he got a lot of extra accessories with it. And he's very generously donated some of these tool holders to me. So thanks very much. So that's excellent. Wow, these are beautifully made. Ground all over. Wow, perfect precision. Oh, and excellent. These are the special ones which allow you to have both a normal lathe tool but also have a drill or something mounted on the same station of the tool changer. So this here's like a ER25 collet chuck. Goes into that location on the tool changer. This is like Christmas. I guess this is probably for tapping. Okay, so this is another special. This is a boring bar holder, I guess. Boring bar. You can also put a collet chuck on that same station. It's also a merch haul. Can, maker of fine CNC machines. Thanks very much. You might be wondering what this little mushroom is. Oh yes, the automatic chuck for the Schaublin. And the rest are a bunch of jaws to go on it. If we look at how a scroll chuck works, basically the chuck key acts through these crown gears to turn the scroll, which moves the jaws. A scroll is nothing more than a thread cut onto a horizontal surface. Now in production, opening and closing a chuck hundreds of times a day with a chuck key will get old really fast, so you need some mechanism to automate that. The mechanism in a power chuck is much simpler. Because you've already got linear motion from the collet closing draw tube, all you need is a bell crank to set that linear motion across onto the moving jaws. As is common in the production industry, the jaws are split in two pieces. So you've got the main bodies there with a serrated drive through onto the actual jaws themselves. These are heavily used soft jaws. You'd set up for each job, you'd first mount the jaws, then turn the jaws to the size of the job, and then you've got the correct clamping size. You've made sure that they're nice and square because they're being turned in situ. One of the jobs I'm going to have to do is make up the T-nuts to mount the jaws. I'll probably need to make up additional jaws as well because all of the jaws I received are getting close to the end of their life, I guess. I'd kind of like to make some hard jaws as well. I got this suggestion. Alternate between hot and cold, see if that moves anything. Not sure if it helped anything, but at least I didn't set my machine on fire. Always put a board down to protect the bed, huh? The work holding collets have got a slot milled into them. The spindle bore is keyed, you can see it here, and that's what stops the collet from rotating. The same collet closing mechanism is used to actuate the jaws of the chuck, so that's why that needs to line up with that key slot. But what I've found is that the rotational alignment of this keyway doesn't line up as it should with the alignment of the three main mounting studs. So this needs to be rotated. Here we can see that alignment problem. Now this should be reasonably easy to push in and pull out. You can see the jaw move. But it definitely feels pretty crusty. Going to need to disassemble it anyway, even if just to clean it, but also to find out how to adjust that rotation. I'm really not sure how to go about rotating the pull stud. There's a little bit of movement in it. That movement is in that whole outer barrel here. This is a pin spanner. I got it for opening up lenses. They quite often use that sort of thing. The cap head screws next to the cam studs are just an anti-rotational device. They stop the cam studs from rotating out of alignment. I wonder why this chuck has so many like hammer marks on it. Looks like somebody's been pretty mean to it. I wasn't sure how to pull this apart, so I actually contacted Gamet, the manufacturer, and they got right back to me in like 2 days and sent me a manual. They say this is the no-go-mo range or something like that. I have to take out the grease nipples, and behind the grease nipple is a screw which I guess locks the jaws or something. Now the problem is they've recessed those grease nipples really deeply there. Looks like it's a 7mm hex. I've got a 3/8 drive 7mm here from Sidchrome from Australia, but unfortunately it's got quite a chamfer on it. You can see it here maybe. And with that chamfer, it won't bite. I'll see if I can break this bolt free. Oh, okay. Wasn't even that tight. Well, that's interesting. There is no spline or anything. There's no real rotational alignment feature. So that's good. It's going to be easy to realign that. Right, well I can't do anything more with this chuck until I get another socket. So let's do something else. So we've got 2 pedals, long and short. 3 pillar blocks that go into the bronze holes. Spring-loaded, where are those? I think those goes on. I think they were in there. Hold the pillow blocks in place up at their holes against the spring pressure while someone from the other side puts in the screws to the pillow blocks and tightens them up from the inside of the machine.
3-person jobs and we are 2.
No, it's a 2-person job. It's actually 1 person and you. So I think we're going to need a somewhat longer tool, huh? Yep, that's the tool. So, how does this go? Like that. Oh. Do I have to take that off? Yeah, I think I have to take the... Oh no, don't have to. Wait a minute, no, I need to get the bumper in. Okay, yeah, go for it. I think so, yeah, it's in. Yeah. Well, it's now the next day, and I've just been to the hardware store and picked up a new socket. But, yeah, just grips. But once again, there's quite a chamfer on here, and I think this diameter is too large. So let's fix that. Luckily, I've got just the tool to change a hardened socket. Now, the standard way to hold your parts on a Clarkson are with these bushings. To get at the part, I need to adjust the wheel down. I know, always use the correct tool for the job, but this is British, so it's got this weird mix of like Whitworth and Imperial and metric and yeah, adjustable. Correct tool for the job. Well, it started out at about 11 and I'm going to take it down to about 9.5, so another 0.3 off. Nice sparks. It seems these days even cheap hardware store sockets are made out of some pretty decent hard carbon steel. Unfortunately, there's no micrometer scale on the Clarkson crossfeed, so you really can't easily get an accurate size. It's something I've kind of been thinking of maybe modifying at some stage. Right, the diameter is good. Let's just clean up the face of it, take the sharp edge off. Now just chamfer the outside, take the sharp corner off. My impression with the Clarkson tool and cutter grinder is it's almost never the tool for a perfect job, but it's always a really fast tool for an adequate job. That socket is now a perfect fit. Now from the instructions, I'm pretty sure there's a hex drive in there to screw out the pivot bolt thing. Unfortunately, my daughter's borrowed my Allen key set, so now I get to go through all the oddballs in the Allen key drawer and see if I can find the right one. Nope. 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 Wait a minute. Nope. 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 Well, a quick bit of cleaning and remembering the instructions. It's not Allen key or hex, it's threaded. Securing that pin is a bolt from the side. According to the instructions, that's just the cover. Yep, and this is the actual pin. Now with that locking pin out, I'm hoping I can just pull the pivot pin. So it's definitely turning. Put a little WD-50 down there. I wonder if this is one of those things you need a slide hammer for. I guess I could also just use a large piece of tube and use the screw as a puller. Oh, that one came out easily. Now we can see where that little grub screw acts against. Now this should just push out, I guess. Or not. Well, 2 pivot pins came out nicely, but the third one isn't. So I've just made up a little puller here. See what is happening. Okay, so that started bringing it out. Aha, there we go. Not sure why that one was tighter than the others. There's no burr or anything I can feel. Now at this point, it should pretty much fall apart. I'm not sure what those 3 holes here are for. They're threaded, but I can't see anything inside them, and there's nothing in those instructions about them. While I'm getting the jaws out, I'll throw all these bits into a caustic solution. Now, some people have told me that glass attenuates the ultrasonic, or was it plastic? I can't remember. Oh well, let's just see. I kind of thought they'd be marked. The first one I took out was number 1, this is number 2. But wonder where that... It doesn't look like Gamet engraves the jaw position numbers, but someone's put a center pop down here in jaw number 1, and then 2 and 3 is still in there. I wonder if there's a bit of a burr in here that's stopping this coming out. It looks like it's keyed so that it doesn't rotate. There's that little cute little key. Okay, so that's a segmented ring there. I don't think I'll bother pulling that out. I'll be able to clean it with it in situ. Well, after cleaning, there's good news and there's bad news. The good news is that this thing is beautifully made, incredibly precise tolerances, and everything's ground, everything's just fantastic. The bad news is that jaw number 2 is cracked. And it's cracked on both sides. Whereas jaw number 3 only has a crack on one side. Now I don't have the correct assembly grease, but it's going to have to come apart again anyway. In aviation, we assume cracks will occur, so primary structure is required to be damage tolerant. Wings, for example, will have multiple spars to distribute loads and offer alternate load paths. The maintenance schedule of a new type is largely generic inspections of all structure. But as experience is gained and the manufacturers learn where cracks are more likely, targeted special inspections get added to the maintenance schedule. All of the analytic tools of fracture mechanics are used to predict crack initiation and propagation rates, and to substantiate appropriate inspections, thresholds, repeat intervals, and the methods. For example, if you have slow propagation, it may be enough to do a visual inspection after crack growth to a detectable size. The threshold can't be too early, as the inspection will be ineffective. Based on human factors, it's assumed that the first inspection will fail to detect, although detectable. So the re-inspection interval has to be short enough to ensure detection before crack propagation changes to rupture. It needs to rotate so that that flat points to this hole. For more critical parts, or faster propagating cracks, you need earlier detection. And since the eye isn't that good, you need NDT methods like eddy current inspections, dye penetrant, or maybe even radiographic inspection like X-ray. I'll leave that loose until I've got it aligned correctly. Camlock studs have a line machined into them, and that's how far they need to be turned in. That line needs to be flush. Right, screw in the draw tube. Let's get some air on this and see if it works. I don't have the air hooked up properly, so I'm just going to use an air gun to blow into the end of the tube. Okay, that worked. And the other way. That's weird. The other way, here's just blasting straight through. Let's open that up and have a look. Ah, darn, look at this. It's obviously rubbing against the piston. Melted straight through, worn through. Guess I'm going to have to pull new tubing right through the whole machine. Man, that's a pain. The collet chuck seems to be working. I mean, apart from the fact that it's cracked. I'll contact the sales guy from Gamet who sent me the user manual. Hey, maybe they want to support the channel with a new set of jaws without cracks in them. Doesn't hurt to ask. But hey, thanks for watching. I'll see you next time.